Improved infrastructure. Good afternoon. Maybe we can start. So today, after having an introduction of the conceptual model, something like we have it here last time, a conceptual model in which you will introduce the temporal aspect that you want to keep into your database. Suppose that now we have a final relational translation of this database, and this database is very simple. We have an employee table which is a non-temporal one, with social security number, first name, last name, birthday, traditional static information about the employee, but then position also. A position is being a professor, being an assistant, being a teaching assistant, being a dean, being a director of a department. So this is the position table, which has a position code number 1, 2, 3, 4, and then first professor, second lecturer, three manager, or etc. So these two first tables are traditional ones, and then we have two temporal tables, incumbents, which say which employee has which position from which time to which time. Okay for that? So this first table is this employee with number, social security number 1, 2, 3, 4, has position 33, which may be dean of the faculty from this date to this date. Then second table, the same employee has this salary from this date to this date. And so we have this very simple database with two columns, independent columns of type date, for representing a period of time during which some information there, the row information, the information reported in the row was valid. So that is a typical example. Look at this, the same employee has the same PCN from this date to this date. That we have, if we say nothing, this is the kind of information that you can freely input to a database. You define a simple relational table without any temporal constraint, and you can have this kind of input in your database. Is this what we want? Let's try to analyze. First of all, look at this, that we use closed open period, so close to the left and open to the right, to enable. So for example, we can say that this employee has this PCN from this date until the last millisecond before this date. So in this sense, we can immediately, by analyzing, since this is open and this is closed, by simple SQL analyzing when this value is equal to this value, we can say what is the next position of this employee. Okay? Look at this. Also, we need some kind of marker that saying it's information currently valid. It depends on your system. Typically, if your system allows, we can have even 99999. So some data types do not allow 9999 as date. So you can put the biggest date it's available in your system. Okay for that? So what we are saying this is that for example, for the last tuple, this employee has this salary from this date until now and in the future. So this is the currently valid total. So look at this also. If we compare this to this, is the same. If we compare this to this, is the same. If we compare this to this, is the same. And finally, this is included in this period is included into that. So basically, we are saying we are using a lot of space for saying not much information. So there is a lot of redundancy here, okay, for that. So we need to avoid this kind of things, but imagine adding for every possible clock that we added last week on our schema. If we allow this kind of information, our tables will explode. So this is the kind of thing we need to enforce, some integrity constraints to avoid redundant information. This is an essential slide that somehow underlines everything we have to say about temporal management in whatever database, not in SQL or in every temporal management or even every extension. Not only, imagine instead of temporal, we are talking about probabilistic information. We need to generalize the relational model for probabilistic information. We have to have the same kind of diagram. So let's try to understand what this diagram is trying to convey. We have a temporal table here. As you know, a temporal table has a set of columns which are traditional columns, and something which are two columns, or maybe three, or maybe four, which represent the validity of this line of this row of the table. Okay, so this is somehow represented with this kind of at the intuitive level. These are the periods during which this row was valid. Okay, for that, this is what we are storing in this table. Okay, so this table is this one. Of course, we need to understand what is the semantics of this table. One possible way to understand the semantics is to have this kind of commutative diagram. So semantics going in this vertical direction is this temporal table is equivalent at the conceptual level as you have a sequence of classical table, non-temporal tables indexed on time. So basically you can move up, down and up in the time to say what is the value of this table which is temporal at a particular timestamp. You get the semantics at this level? So this is what we say. Of course, we cannot store this in this way in a hard disk because it will be very expensive. But for humans, this is what we mean. Okay, for that? Now we need to define temporal joins, temporal etc. on these operators, on these tables. Okay? How do we define in a correct way what would be the correct result for a temporal join, temporal aggregation, temporal count, temporal average? The beginning is difficult what will be the right answer. One possibility is to define this operator again, to understand the semantics at this level. Suppose that these are three values of this temporal operator of this table at three different timestamps. Suppose that we are working on the temporal projection. So projection is removing some columns in the traditional tables. Suppose that do a projection here, the same projection here, the same projection there. You obtain the result of this projection at the semantic level. Okay? So again, we take as input a set of tables indexed of time, apply the classical projection or selection or aggregation or join, etc., and obtain a set of tables, a set of result tables in the same indexed in time. But of course, we are not wanting to do that to each time we need to do a join or a projection, we need to materialize all these, apply the operation at this level, and again go back at the representation level. No, this is our semantic. This is what we want to obtain at the end. We need to define the projection at this level, at the upper level, to say, I'm sure that this temporal projection, temporal join, etc., are correct. Take an input temporal table and produce an output result, which is also a temporal table, and we apply the semantics of the result in this way, and this result obtaining from here down and to the right should be the same that from up, right, and then down. You get the idea of this commutative diagram. So this is the basic idea to generalize whatever you want. It's a traditional encoding way to generalize things that you are, this thing you know. There have been 50 years of explanations and proofs and formal theorems about relational algebra. So all this is very well known. We want to extend this for probabilistic, for fuzzy information, for whatever you want. Then start from something on which you can base from. When you have this mapping and this, you apply this classical operation that you know for 50 years, try to get the same result in a single step. You get this commutative diagram, this is essential. When you understand this, then the rest is easy to understand.
Okay, if that's the case, then I have to ask some questions. You're using the word semantics. I don't really understand what that means. Like when you say apply the semantics, like I don't really understand what semantics means.
Semantics mean what are you trying to represent? Suppose this table, right? This is not the right table. Let's have a nicer table. I don't know where I can find a nicer table without these errors. Imagine I will then produce one. You are saying you are maybe here. You are saying that John. I have it in my first lecture. Is it here? Yes. Suppose these are the two nice tables that you want to say. John has the salary during this time. John has the salary during another time. The same for the title. I would like to obtain the temporal join like this. And what I was meaning here is that, say, the semantics is like I have a traditional table for John here, in which I say John has 60 at a particular time, and John has 70 at a particular time from this time on. So this is what I mean. At each point is T1, at this point T2, I have a traditional table. So this is what I'm trying to encode in a very compact way over there. And then I have the same for John was assistant here, so this is another T, whatever T. John was then lecturer somewhere else. I don't want to do it exactly the same. He was lecturer there, and he was lecturer, he was professor there. So a different evolution. So you need to basically, when you do the join, you have at this point John was also assistant, so you produce a temporal join of these two values. Sorry, a join of these traditional tables at this timestamp. And by accumulating all these, you should obtain the result of this.
So when you're saying semantics then, are you just saying that it's like a translation?
Yes, an encoding, a compact encoding of this evolution of the parameter.
Okay. And so for that slide that we were just talking about, the concept to understand from this is that either I can go from one temporal table to another, or I should be able to go from a temporal table to a traditional table. And either way, whichever way I want to, I guess, think about it or execute an operation, I'm able to move through the tables in that way.
So I mean, this is what we are doing. How do we compute the temporal join there? But to understand what does it mean, what will be the resulting, you need to compute that into your SQL queries. But your SQL queries are SQL does not understand much about temporal things. So you need to be sure that when you do this in SQL, the traditional SQL, and you are sure that you take the right results. And the right result will be, I mean, with this small example, you immediately understand that this evolution is independent of this evolution. At a particular timestamp, you have one particular value for this and one particular value for that. And then you need to do the result in as much as compact as possible way.
And so when we're doing temporal operations, are we always having to move into a classical table to do it? Or are you going to show us ways that we can do it without using classical tables?
I just want to show that this is the right result I would like to obtain. This is the right result. Why I would like to obtain this is the classical, this is the result I want to obtain. And then if I write my SQL query and I don't obtain this result, something is wrong in my SQL query.
Okay.
So this is, you understand this idea of semantics now? So I know why this is the case, that this is the right result, but this is the most compact way to do the join of every table at every possible instant.
So that we don't have like redundancies, that we have multiple overlapping.
Yeah.
Okay.
So this is the kind of thing we would like to do, but of course we need to do this at the level of the temporal tables. And that is complex in SQL, as I mentioned. But before that, we need to go a little bit in verifying which kind of operations we would like to solve. The same go for queries, for integrity constraints, for triggers, whatever you want. The same idea. It's like you apply a single trigger that verifies your constraint at each instant. But you don't have this representation, you have the compact representation with the two columns for the from date and to date. So let's see the requirements. Thing that a manager can ask to us. Which is the current position of Bob? So these are called current queries. Or which is the position that Bob will have at a particular date, or will have a particular date if we have also future data in our database. The sequences are the complex one. What is Bob's application history? Position history. Then this is the problem which we need to do this fusion of interval that we have seen already at the beginning of the lectures. And finally, the non-sequenced, the sequenced is this semantics. The non-sequenced, somehow they are kind of queries we can forget about the temporal aspects. They are not taking, we'll see examples. These are a little bit more easier than the sequenced queries. So let's start with temporal keys, traditional keys. So you remember this employee have this position from this date to this date, to the other date. How do we define the key of this table? What will be the key?
SSN plus TCS plus from date.
For example, this is the one, and why it is better than to date, or why it is better than from date and to date? Which of the three we will use?
Because if it's a sequence of dates, for example, there is no stop, we can assume that every single time it will begin with the from date and it will end with the from date, because the to date is not inclusive.
Yes, you get the intuition, but not enough details, technical details. So indeed, we can say, if we say that SSN, PCN, and from date are, it's a key, the first two, this, let's see first, is this something that you would like, the two lines that are there? You would like to have this on the data on the table or not? Would you have this or have a single line? Single one. You get the idea, because these two periods are overlapping. So you get the idea by putting SSN, PCN from date, it could be a key. Putting to date could be a key. Putting the four attributes will be a key. But does not prevent this problem, but which is already there. Which is there are overlapping periods for the same employee or for the same position.
So we're gonna create artificial or no? How was
A trigger. So basically we need to avoid for the same SSN and PCN that we can find two distinct tuples that overlap. They can meet. If they can meet, then we can join both the two. But if they overlap, we have a problem. What we are going to suppose that this employee is Dean. Is Dean from this date, and is Dean from this date and this date. What are you willing? Suppose that they are deans of at the same time dean of two faculties.
Well, it's kind of impossible to be dean. Well, but let's imagine, because sometimes really something ridiculous happening.
But
yeah.
it really depends on the application semantics. It is possible to be two deans of this different faculty. Maybe not, but suppose it is. Then we can accept that SSN plus PCN plus faculty would be the key.
Yes,
And then in that case, that you can allow different, same PCN, but for different faculty. Suppose that there is a rector in any university, there is always a single rector. Of course, in that particular case, you need to avoid that two persons have twice the same position at the same time. And then the idea, the problem would be, can a dean be later on a dean? How much number of a president of the whatever country or prime minister how many times he can be successively a president or a prime minister? There are always restrictions on that. Maybe one time he can renew, but not two. Re-election in the United States is only once. At the ULB you can be rector a half period after. So we have the first 4 years, and then you can extend for 2 additional years. All these need to be encoded in SQL and in triggers. You get the idea. When you put temporality into account, there is a lot of different little details that we need to take into account into our database. Okay, with this, yes?
Why, I don't understand, why do we ask what can we change about our keys?
My point in this slide is that whatever key you define here, it does not solve the problem.
Ah, okay.
So yes, we need keys. The keys solve the most bigger problems, but this is not enough. We need to complement, and keys are easy to, keys are faster. So with the keys mechanism, traditional key mechanism, you can solve many problems. But this is not enough. After the key, typically we have SSN, PCN, and from data as just been proposed. But in addition to that, we need to have triggers. So one possibility is this. Can someone, I mean, I can do it myself, but to understand whether you are able to read enough SQL now after 1 month and a half here with us, can you try to explain what everything before the OR? Can you someone try to explain in simple terms? You remember incumbents is this table. This person have this position during this period. So how can I explain the intuition between that? Or for this trigger? I don't know how to put much light in your. It's better like this, probably. So, who wants more? So, can someone try to explain the intuition here? Maybe the inner select is easiest. Let's start from the inner select. From this select count.
If there are multiple entities of SSN and PCN where dates are overlapping, the count will be more than 1, so trigger will execute.
So let's start with the 2 and there. From date to date, look at this, 1, 2, 2, 1. From date to winter, one less than other. This is a pattern. Whatever you have this, you should immediately understand what we are talking about. What are these 2 lines trying to solve? Are overlapping. And then you remember that 2 periods can overlap in 4 possible ways. So here to the other way around, here and here. And the last one will be this to the right and this to the left. Okay, for that, this is from date and this is to date. Okay? So look at this. You remember that we have seen all these only possible way that 2 overlap, provided that this is closed and this is open. So we are saying from here is less than this and from here is less than this.
Can you please explain what is
one, right?
Sorry?
Is it the last one overlapping?
All these 2 lines goes with all the 4 possible variants. Look at this. In this case, this is less than this and this is less than this. In this case, this is less than this and this is less than this. In this case, the same, and in this case, the same. Sorry, I'm mixing there. I need to cross it. This is less than this and this is less than this. What happens if we have, sorry, I will put it like this and put it like this, just at the same instant. Is this less than this? Yes. Is this less than this? No. So in this corner case, when 2 are one starting the other, these 2 lines do not fulfill, they are not so satisfied. Question?
what do you mean by open and close? And sometimes we can see that there is something like less than equal and sometimes
Open
not.
and close is this. This employee has this piece in from the first millisecond of the from date to the last millisecond before the next date. So you are ensuring that here, and therefore, so you can have this, so this value until the last millisecond before the 1st of June. So suppose that we have another, he was rector here and then he was dean, or the other way around. Then at midnight of this day, he stopped being a rector and now he is only a dean.
Okay, so the to date is inclusive.
I mean, not implicit. You are saying it is valid until the last millisecond before that. And this is why it's important to encode open at the one at the right. No, sorry, close at the right and open to the left to be able to. Otherwise, if you accept this, you will need to put until 199601 until 19996. Then you need to verify how many days are in May. Are there 30 or 31 days in May? I know that this 31. So you need to do all this computation by hand, and then when you are verifying which is the next position from this employee, you need to add 1 day here, and that's a lot of computation for nothing, because you can encode. It's just an encoding. When you encode like this, your SQL query will be much simpler. Is that answering your question? So given that, look at this. This, in all 4 possible cases, these 2 lines of the SQL of the trigger. No, it was not this one. Where is? Yes. In these 2 cases, there is an overlapping between the 2 lines. So look at this. Now we are able to read this thing. You find one line which is called I1. You have it in your left hand. You know where is the SSN of this one and the PSN of this left, the one in the left hand. Then you sequentially scan all the rows in the table. This is the select from incumbent, that's E2. So you need to scan. When you have this on the left hand, you start with a sequential scan of the same table. And you need to count how much of these tuples are in intersection with the others. You will have at the end the same line you have in the left hand. Okay, for that, sooner or later you will find that line. If there is more than one, then you have 2 records for the same SSN and for the same PCN. Then there is an error. You will need at least to have 1. Okay, this is the traditional way to see. If the count is bigger than 1, I have at least, there is an error. Okay, for this query. And then this other part is simply saying that in the case of when this SSN or PCN can be null. But if you are sure that SSN and PCN are part of the key, then in a key you cannot have null values. Then you can remove these 2 lines over there after the OR, because you are sure that there will not be null values for SSN or PCN. So again, in addition of defining your SSN or PCN and from data being the key, you need to add something here for ensuring that there are no overlapping intervals for the same SSN and same PCN.
So we are creating sequential key, right? It's just we are creating this count.
One question. I accepted here that an employee can be, I don't know, an employee E1 can be lecturer from this time to this time, and the same employee can be, I don't know, dean during this time of this time. So we are accepting the same employee have 2 positions overlapping in time. This is a typical case at ULB. In many companies, you have a single, you are at a particular salary scale or a single position. how do I modify this trigger to ensure something which shall disallow this? That I cannot at the same point in time two positions.
If the combination of SSN and PCN is in the key, then this won't be a problem.
Oh, so you just need to.
You need to check this as well as a key.
I need to do both things. First, in that case, what will be my key of this table?
ESN plus SN plus this.
SSN plus from date. At a particular point in time, I have a single PCN.
PCN is position.
Yes.
PCN is position for each employee.
Yeah.
And so I modify my key here. How I modify my trigger there?
The interval, which overlap.
From date and to date, it should remain. What about removing and I1 PCN is equal to I2 PCN? I will, in the same way, I have in my left hand a single record for this employee. And I look how many records of the same employee unique, independent of the PCN, and verify that the period will overlap or not. So by simply removing PCN there, or PCN there, then we have the single constraint ensuring that an employee has at each point in time a single position. Yes?
What are we gaining by putting from date or to date into our key?
They avoid particular kind of errors, like suppose that you don't know that you have already introduced your employee and your employee is on a fixed contract for 3 months or for 3 years. Then you avoid at least introducing twice the same data from the same employee. But the same employee can have several contracts. Filter some of the problem, not all. So, in essence, what I wanted to discuss here, forget temporal issues. If I say an employee has a single position in time, what will be the key of this table? If I remove this. An employee can have only a single position at every point in time.
ID plus position.
Yes, but now I have 2 business constraints. In ULB, I can allow this. In a bank, an employee can only have a single position. How to define the key in each time? So my first question, to understand how to deal with that, let me try to find a trick. Let me find a trick. Let's open whatever. Yes, here, for example. Suppose that your table is like this. So forget the temporal aspects. When I say at ULB, an employee may have different positions. If you forget temporal aspects, the table is the current valid information. So if I say at ULB, I can allow a single employee be at the same time professor and dean, what will be the key of the table?
SSN plus PCN. SSN and PCN both.
All of the rows.
But no, I say if this is the case at ULB, this is a full table. Both are needed for the key, because I can be this, E1 appears twice here in the table.
Oh.
Suppose that in a bank this is not accepted. An employee has a single position in a bank. then your key is
SSN only.
SSN only. So my methodology for you, for myself, for everyone, please think first in terms of non-temporal tables. When you have your constraint there, which is, it is only SSN or it is SSN plus PCN? When you have this in the normal case, you add from date and the problem is solved. Okay, you get the idea? Yes.
For ULB case, you're saying that we will have SSN and PCN both as key.
Both as part of the key, and in the temporal case, you need to add the from date. Yes.
Regarding, I know that we have overlaps there, so, but in the case we didn't have overlaps and we have like the sequence, like the previous table you showed, any of those three candidate keys that are in there would be valid, right?
Yeah.
Okay. Is there like any scenario where we should choose like one versus the other, or are they equivalent?
Difficult to say. For me, I would say they are equivalent. Each of those tracks some kind of error, but not all. As typically the last date is open, so for many cases it's better to have it at the from date, because now this one is always known. The last date can be 9999. Maybe for this it could be better to use the from date as part of the key. But again, my position is very clear. Please be sure that you understand these things before temporal. When you have this and you know where the key is SSN only or SSN and PCN, then you add from date and the problem is solved. Okay for that? So now again, we say that we put the maximum date in our system for our due date. So in our example, we put this. In many databases, we put 99990131 to 12. We can use null. Null to say it is currently valid. What are the advantages of disadvantages of using null or using a date very far away?
Using null, we might not be able to compare when we are turning or putting it.
What is the problem with null values?
How can we compare with the other dates? Like null cannot be compared with null.
So the problem is null is some kind of absorbing. As soon as we put null in an operation, it gets null and then it propagates all the nulls. It's complex. So indeed, we could encode the information of very far in the future with null, but so in order to identify where will be the current record, where in converse to date is null, but then we cannot compare. We cannot do any operation with null. So it's not ideal. But in the same way, philosophically, we are representing valid now. And I don't know when and always, the difference between now and forever, there are some nuances on that we cannot they cannot differentiate when you put a single date in the future. So, but this is a limitation that is imposed to have a better performance for our SQL queries. So now let's go for duplicate. Same table as before with all these problems. There are different ways to do it. So the first way to say is they are value equivalent if all the values without this, so these are temporal value equivalent because all the non-temporal attributes are equal. There will be sequenced duplicates if for example here, if we think at these first two lines between April here and June here, the employee has two positions, twice the same position. This is somehow sequential duplicates. But at the same time, we could have only current duplicates, because suppose that we are in this range. If we are in this range between, suppose that we are in 1997 something, then only while the current time is at this date, we can find the current duplicates. The idea in current duplicates is as follows. What is important, this concept? At the beginning, the table is empty. If you ensure that each insert in the table, all the current duplicates are removed, there is a constraint for the current duplicates. When you accumulate that against all the time, then by definition it will always, in the past also will be, the constraint will be valid, and it is much more faster to verify current duplicates now instead of analyzing 10 years of history. You get the idea? So current duplicates is an implementation concept that if you accumulate in the beginning of the table, it will always be clear, be valid. Of course, you need to be sure that every tuple that is inserted now is valid, but then by accumulating history, it will all valid throughout the history. You get this intuitive concept? Suppose that you have 1 million table. At the beginning, this 1 million, the rows table was empty. But you were verifying that the current update was correct. After 10 years, even the past update will also be valid. And then you only need to verify the tuple that are current now. Even the closest one, they were one time open, and at that time we avoided the problem. We will see the example, but the intuition, you understand. If you do something little by little, at the end you get the full result of the sum of all your efforts. This is much less expensive than each time verifying the full history. For verifying the whole history satisfies the problem. Okay, for that it's an implementation called incremental way to, in the same way as we discussed the previous lectures about incremental updates of the materialized views. Of course, you can throw away your view and then recompute it from scratch. In this case, will be, of course, you can verify from the million tuples whether there are some intersection of periods. This is expensive. Try to do it each time the database is modified, and then by definition it will be valid for all the whole history.
Is it true that every current duplicate will also be a sequence duplicate?
If you ensure that every update of the table is current duplicates, and you don't update the past and you don't update the future, then it will, by definition, all the history will be also valid.
No, I just mean, like, by definition, if I say that something is a current duplicate, can I also say that it is a sequence duplicate?
Yes.
Okay. So it's just a matter of perspective.
Yeah.
Of what date am I looking from?
Exactly. Again, it's shifting in this timeline here. So this one we all, yes, look at this example. You remember this? No, this one. So now suppose that you have 1 million rows in incumbents. We need 1 million times 1 million, and compare 1 million combinations. One possibility to do the same with less costly is to do like this. Basically, you do the same trick, but you filter only for all those that are currently valid. And then instead of 1 million, you have only as many employees you have now. 5,000 employees for the ULB. You don't have all the history of all the, it's in 1970s, 60s or 70s. You get the idea? No?
No. Why are we saving? What's the difference? What are we saving?
Look at this. You understand here that here at ULB we have the position of all the employees since 1960s.
Here we are checking all of them.
Yeah.
And
in the next one, so you understand that 1 million times 1 million is very expensive.
yes.
So now it's similar, but we are filtering here from current, the period in from date and to date includes the current date. So these two lines, we are saying in this period includes to date.
Is that like checking for only the employees that are current employees of the institution instead of, I mean, not looking at the employees that were employees at some point, but
It is.
contextualizing on now?
Yeah. You get the,
So we're dividing our time into some blocks, and we have blocks
No.
which are already closed, and now we are checking blocks from current date.
conceptually yes, but let's see a more operational, a more easy way to say. You have 1 million rows here, and we have only 10,000 for no 5,000 for the current employees of the ULB. That the current date is between this interval. You throw away you only look toward these 5,000 rows instead of all the million rows,
Okay, I got it.
because of this filtering here that was there, because of this filtering. But you will need to sure that you put this constant at the beginning of the when the table was empty. And this is every update goes through this trigger. 30 years later, it will always be the case. Yes.
What would current date be?
Current
It's a scalar that's outside the table, or is it something that would?
current date is the SQL way to say now or today or
It's like a get date.
get date in SQL Server. SQL Server is not standard. So current date is the official standard way to do it. You get the idea? So it is much less expensive to do that. Of course, even here we can have an improvement of this query using what? Using the inserted and deleted table. In that case, we only include the 2 or 3 lines that the 2 employees that we just hired. So think of optimizations, because temporal is expensive. You need to gain cycles of CPU here and there. So all these. Yes.
Just one question. Regarding the example that you just gave, it would highly depend on what you want to do if you could do that, right? Because if they are asking you like for all the history from the start of time of UOB employees, you wouldn't be able to do that, right?
But look at this. This is I was trying to escape this discussion, but you put it into front to complicate things. Look at but this is a perfectly valid consideration. Constraints change. So, for example, suppose that at the beginning in our bank, it was possible to have 2 positions at the same time. And from now on, from the current date, from 1st of January 2021, this is not allowed. Of course, you need to keep the past. And only verify that your current, so the past, you cannot change it. It was valid at that time, but from now on, you can only have a single. So you need to accept this for the new updates and keep the old history as it was. So you get the idea. So depends really on the business. We are implementing business rules. Business rule can be as complex as we can imagine. Marketing rules are even more complex. So you need to encode this sooner or later in SQL, and that's painful. Let's put it in this way. So all these are variants of the same. We discussed that this is the same query with only SSN and without the PCN that we already discussed that. Now, referential integrity. This is another important topic. I would propose a break, and then we take temporal referential integrity into account after the break.